You may have noticed that this course is divided into sort of two topics. The first topic is virtual computing, and the second topic is cloud computing. We cover both topics because cloud computing can't exist without virtualization. Virtualization was a very important technology that supports cloud computing. In this course, we not only want to understand the cloud and know how to use the cloud, but we also want to know how it works and how we can configure and set up our own cloud environments. So if we wanted to create our own private cloud, we would have some understanding of how that works and how those technologies support that. So to that end, we're going to start with a discussion on virtual computing. In this unit, I give you a brief introduction to virtual computing, things like VMware, and a little bit of how those hypervisors work. And we're also going to talk about cloud computing. I'll give you a brief overview of cloud computing. We'll tie it back to some of the virtualization concepts that we talk about. But then we won't talk about cloud computing in earnest again until probably the third or the fourth unit. So first we're going to really try to understand virtual computing. So let's get started. So first I'll start with an overview. We'll talk about some different virtualization products that exist. And then we'll talk about virtualization in the data center and then virtualizing applications and some of the features of these different hypervisors. So let's go ahead and get started. So an overview of virtualization, I'm sure many of you have heard of the term virtual machine. It's basically can run its own operating system as though it were running on a dedicated computer. A lot of folks who take computer science classes sometimes get confused with the term virtual machine because the term is also used in other areas with software development. But in this context, we're talking about virtual machines as being an operating system that's running in a dedicated computer, as if it were running in a dedicated computer. So it's as if you have a computer running inside a computer, so you can have multiple operating systems within a single computer, or multiple computers running within a single computer. Virtualization software includes a lot of the features for managing computer environments. So usually when we talk about virtualization, the software that actually does the virtualization is called a hypervisor. So you hear the term hypervisor throughout this course. And again, when we use that term, we're talking about the software that creates the environment for the virtual machine. It's the actual software that controls and creates the environment for using virtualization. There's two types of hypervisors. The first is a type 1 hypervisor. Sometimes you'll hear people call that bare metal hypervisors. They run directly on hardware without the need of a host operating system. So I guess if I had to summarize, a type 1 hypervisor is the operating system. So instead of an application, the hypervisor, when it's a type 2 hypervisor, is an application that's running just like any other application within an operating system to create an environment from which you can run another operating system in its own dedicated little computer. Where a type 1 hypervisor is the operating system itself. The hypervisor is also the operating system. So it's not that there is no operating system, it's that the hypervisor is the operating system, and it's geared towards that one task of providing a virtual environment. And one of the things that we'll learn in this course is that type 1 hypervisors are much better than type 2 hypervisors when it comes to virtualization. They're much more efficient. You can run more machines. Lots of good reasons to use a type 1 hypervisor. The flip side is the type 2 hypervisors are easier to install, so pretty much anyone can install them, just like any other application. They're not hardware specific like a type 1 hypervisor because they run within a different operating system, so a lot of that stuff is abstracted. And they can allow you to use your normal desktop applications while you're still running a VM. So you can have your virtual machines running while still using your Windows desktop, for example, or even a Mac. So definitely type 2 hypervisors have their place, and we'll talk about some of the uses of both of these different types of hypervisors in this course. So a host computer is the computer that is running the hypervisor, whereas the guest OS is the actual virtual machine. So when you see the term guest OS, we're talking about the VM, and the host computer is the computer that is hosting the hypervisor, or from which the hypervisor is installed. So here's how it works. The hypervisor must provide hardware resources dynamically to each virtual machine, and each virtual machine shares the computer's hardware resources, such as the CPU, memory, disk, keyboard, video, and so forth and so on, all the I/O ports. So all of those resources have to be shared amongst all of the virtual machines. So it's important to be aware of that when you're planning virtualization, to understand how the hardware is going to affect the performance of your virtual machines. So the hypervisor basically intercepts and processes requests coming from the guest operating system, and then it returns results back to the VM after it carries out those instructions. So in addition to the hypervisor, each VM has two main files. It'll have a configuration file, which has all the settings for the virtual hardware, and it will have a virtual disk, which is the actual hard drive for that virtual machine. So it'll contain the operating system image, it's all of the data, and so forth. Sometimes you can have many disks, not necessarily just one disk file. And they can also be on SANs and things like that, on network drives. And we'll talk about those things later when we talk about enterprise virtualization. So a virtual machine's disk system may be stored as one or more separate files on the host computer's hard drive. Peripheral devices can be shared by the VM's host computers, such as network interface cards, your USB ports, peripherals and things like that, printers, USB ports, keyboard, mouse, all of those things are shared. So the hypervisor's job is to basically mediate some of that sharing between these different resources amongst the different virtual machines, and also to abstract that from the virtual machine and interact with the operating system. As I said, in some cases with a Type 1 hypervisor, the operating system is the hypervisor in that case, which, as you can guess, makes it much more efficient. So as far as hardware and software requirements, so the host computer requirements will depend on the type of software that's installed. So with a Type 1 hypervisor, the computer installed must match the hypervisor's requirements. And this is one of the challenges with Type 1 hypervisors. You can't just go to Dell and buy any old server and install a hypervisor on it that's a Type 1 hypervisor. You have to ensure that it's compatible with the hardware. There's generally more stringent hardware compatibility requirements with the Type 1 hypervisors. As for the Type 2 hypervisors, they're a little bit easier. It just has to be compatible with the operating system, the version of the operating system as well, on the computer in which you want to install it. There are some hardware requirements. Sometimes there are limitations with microprocessors, but it's usually a little bit more forgiving than the Type 1 hypervisors. So processors have to support virtualization. Usually they require multi-core processors, although I don't think that's always the case. But certainly it's recommended. Hyperthreading is used to create additional virtual cores used by the hypervisor to improve performance. You also have hardware virtualization, which performs part of the virtualization process inside the microprocessor to help solve performance issues. And then you have data execution prevention, or DEP, which helps you isolate different VMs when you enable that feature. And that's something you can turn on in Windows. So as far as memory requirements, it's based on the combined memory requirements of all the guest systems that will run concurrently. So it's sort of a sharing, a time sharing type of situation. So you have to ensure that you have enough memory for the maximum memory usage for all of those virtual machines that will be running at the same time. So the host system must have enough memory to run the host operating system, all the guest operating systems, and the applications that run on the host and the guest OSs. The shadow page table is used by the hypervisor to keep track of the memory pages allocated by each guest. And then the second level address translation, or SLAT, makes it possible to avoid overhead associated with software managed shadow page tables. And it improves VM performance. SLAT has to be supported by your microprocessor. So the processor and the server from which you're running the VM has to support SLAT in order to realize the benefits of SLAT. So storage requirements. Once again, you have to add up all of the storage needs, so all of the disks. Because remember, you have to use the, you have these virtual drives, but they're going to contain all of the data for the virtual machines. So you have to make sure you know what the maximum storage size is going to be. Luckily, most of the Type 1 hypervisors will allow you to dynamically change the disk utilization. So you don't have to, it's not set in stone once you create that virtual disk. So that's a nice feature in most hypervisors. So you can use a local disk for storage, which is the simplest way to configure the hypervisor, whether it's Type 1 or Type 2. With data center virtualization, such as vSphere and Hyper-V, you can also use SANs. So you can use network-attached storage or storage-attached networks. We're going to talk more about that later on and how those work and how they relate to virtualization, but you can also use storage drives. I'm sorry, you can use network storage. So as far as network and peripherals, the VMs can be configured to use the host computer's network interfaces. In data center applications, the host computer may require multiple network interfaces to provide higher network speeds and support clustering and load balancing. So sometimes we'll have multiple ports on a virtual machine that's hosting, or on a hypervisor hosting many virtual machines. You might want to have multiple network interfaces so that, number one, for speed, multiple connections to the network, but number two, for redundancy.